Welcome back to Talking Fire.
Once again.
Myself and Clive are here on our white couches again. So the next topic of discussion is we're going to put it under good installation practice, but focusing on aspects of installations which seem to be questioned a lot and recurring a lot. So the one that generally as an association we try to steer away from cable, due to the fact that there's multiple cable manufacturers, the requirements in terms of actually proving that your cable is a PH30, that it is EN 5200 approved and all that kind of stuff. You know, as an association, we've never been focused on running with a brand or promoting a brand or a supplier, so to speak.
Correct.
Okay.
Yeah.
So first thing I want to ask you is what type of cable? Obviously, in the day, we started with F420. It was a 0.8 mil conductor.
Cable.
That got changed out to PH30, PH120. When do you use which and why?
I'm going to refer to the standards. Okay. PH30 means that the cable can withstand fire condition for 30 minutes. That's very basically. However, the testing of the cable is quite complicated. You've got to have a ribbon burner of 800 millimeters. You've got to have a constant heat of 800 degrees Celsius. So there's quite a bit, but sort of basic layman's terms, if you're looking at a PH30 cable, you are looking at a 30-minute fire rating. If you look at a 120, PH120, you're looking at 120 minutes rating. That's the basics of it. To see what your cable is, so your critical path needs to be 120. Normally you're using 120 for voice evacuation systems and that. And your detection side of it is normal to use a PH30.
Okay.
That's sort of very basic way of looking at it.
Okay. The next question. Obviously, post FR20.
Yeah.
The need to run all your fire cable in containment, so whether it's Bosal, conduit, or whatever, is no longer required.
Yes.
Now the question always comes back to fixing the cable. Okay.
It doesn't just float in the air.
So obviously you need to fix it neatly and all that kind of stuff. Are there certain requirements? Do I go to the hardware store and do I just buy normal cable ties? Are there requirements? What type of fixing? Is there a fire resistant rating required? What are the requirements in terms of fixing the cable outside of containment?
You just go to the hardware store, you get a bit of string and you tie it up. No. Okay. And I've got the standard, and it says. So, and I'm just going to get, where is this? It is under 8.19.2. Methods of cable support should be non-combustible. So there goes my piece of string out the window. And such that the circuit integrity will not be reduced below that afforded by the cable used. Should withstand a similar temperature and duration of the cable while maintaining adequate support. So, you're using PH30, you need a method of hanging this thing up that is going to last for 30 minutes.
Okay.
You're using PH120, you're going to use that. There are companies that sell a fire-resistant cable, which is a plastic type cable tie. Or you use stainless steel, you can buy stainless steel cable ties.
Okay.
Going a step further, it says, in effect, this recommendation does not allow for the use of plastic cable, clips, cable ties, or trunking. Where these products are used as the sole means of cable support, PVC conduit should be permitted if special attention is given to the support method of the conduit as to prevent the collapse of the cable network under fire conditions. i.e., cable support should be non-combustible, for example, steel. The distance between cable supports should not exceed 500 millimeters.
So if I'm running, just to speak, so I'm running my cable in conduit, I need to put a steel saddle every half a meter.
If you're using PVC.
If you're using PVC, Bosal is non-combustible, so we should be okay as long as it's done.
There are companies that sell fire-rated clips. So, for instance, Hilti and Ramset, those type of companies, they sell a clip that is steel. Then you can shoot it into the soffit, into your steel work, whatever, and it's a steel clip that is fire rated, and you can put your cable in there and it clips it up. Okay. But it's got to be a method that your cable integrity, your fixing is not going to be less than what your cable is.
Okay. So now just to move on to something, and I'm going to ask you this question as you being more on the contractor side. It's apparent we seem to prefer, well, that's a generalization. We prefer a 1 millimeter squared stranded cable.
Yeah.
Whereas quite a lot of the world like a solid core. Okay. So now your technician's having a bad day. What would you tell your technician to do, and how would you action it to ensure that when terminating the cable, you are still maintaining that full 1 mil squared connectivity between the device and the cable? Mm-hmm. Obviously, that's for loop calculations. There's a lot of factors around that. Everything is based around the cable and the thickness of the cable. I have personally seen it before where possibly half the strands didn't make contact. So we're dropping down to a 0.5. Therefore, my loop load is exceeded. My resistance has changed. So as a contractor side, what would you do, and what would you recommend that other technicians or people train their technicians in order to maintain that connectivity and to terminate correctly?
All right. So obviously the first thing that is most important, proper tools. You're not going to take your steak knife from home and cut the installation and pull it off. You get proper wire strippers. You got to strip and make sure that all your strands are there still. Secondly, as your strands are like that, twist them together nicely so that they're all cohesive, and then you put that into your terminal. Look at what you're doing. You can't work, we gain a bit of health and safety here, but you can't work in a dingy place. If you're working in a new building that's not been commissioned yet and there's no lights, get a head torch so you've got proper lighting so you can see what you're doing. Be careful with what you're doing. Make sure that you're doing a proper termination. It's just sort of good practice. We're going to go now to a little bit of the competent person. There are courses out there that you can put your technicians on to become an installer and a cabler and so on. So they give the guys training on how to use the tools properly, how to do proper terminations, how to use the right tools to do the right job. Okay. So you don't rush it. It's better to take 5 minutes to do the job properly than 2 minutes and you have to go back 3 times to fix it.
Okay. To finish off on cabling, I would always say branding on the cable, EN 5200. All the batch number should be on there.
Yeah.
Certification should be available from suppliers.
Correct. Yeah.
And these kind of things. So just once again, a recommendation. If you are happy with your supplier and they've provided that information in the past, stick with your supplier. There was as with anything.
Yeah.
The growth of with the growth of demand becomes the growth of supply.
Yeah.
So we did see some cables being brought into the market.
Possibly not what it should be.
Yeah. So just check that the cable you're doing does comply to all the standards.
And also use your brain a little bit. If you're getting a cable from somebody and supplier A charges you 100 Rand for a meter cable, supplier B charges you a Rand for a meter cable, I'm going to think there might be a difference, So cheapest is not always best. Obviously, people bring in bulk and they get better pricing, but all the cabling should be similar kind of pricing. You're going to have 10 Rand at 10 cents difference between the two cables. If you've got 10 Rand between the cables, ask the question, certification, is it being tested correctly? Because ultimately, you're installing it, you're going to be responsible for it. Best practice, make sure that you're confident by yourself to know that is the right cable.
Yeah, okay. Just moving on to the next topic, batteries, okay? Now, under the current power generation situation in this country, the challenges aren't as big as if we had done this video maybe 6 or 8 months ago. However, batteries, okay, I'm going to start by saying the importance of battery calculations sometimes feels overlooked.
Definitely.
You need to make sure the 30 minutes in alarm, 24 minutes standby.
24 hours, not
24
minutes.
hours, hours. My apologies.
Yeah.
So that is important, specifically under when there's no mains.
Mm-hmm.
A system that's overloaded is going to cause your battery to deplete quicker.
Mm-hmm.
Okay. And that kind of stuff, it needs to be labeled. When you install new batteries, get a label and put the date.
It's a
part of the
requirement on the standard. It's a requirement, yeah.
It's not done that often. From your side, anything else in terms of batteries specific? There was the talk for lithium batteries in fire panels. That's obviously charging rates and all of that kind of stuff.
Yeah,
made it a bit more of a challenge. There are some panels in the market that do require them, but that's once again between contractor and supplier to discuss that in general.
But just be aware, okay, so batteries. Also, in the standard, it does allow for, if you are expecting load shedding, it does say that the baseline is 24 hours in standby plus half an hour in alarm condition. That's your minimum requirement. However, that standard does say if you feel that your power supply is not going to be adequate, you can allow for a longer period on your battery calculations. And it is a requirement in the standard to put that battery calculation in your handover documentation. Lithium ion and lead acid and. You can use lithium ion if the panel has been specified for that. The charging characteristics are completely different. A lot of people is just slapping lithium ion in, and I think we have covered this ad nauseum, but just to reiterate, if the panel is not designed for lithium ion, don't use it. It's as easy as that. Batteries, mark them, they got a lifespan. From the manufacturers, they suggest every 3 years. So if you haven't got a date on there, how do you know when it was installed?
Check your charges.
Check your charges, yeah. When you're servicing the system, you should check that your charging rate is still there, that everything is working correctly. That is part of your service requirements.
I do stand to be corrected, but I do believe that EN54 Part 4
You're right.
is tested in accordance to the type of battery
Yes.
that will be used.
Yeah.
So should somebody take it under their own advisement to change from lead acid to lithium, it's potentially then over and above the manufacturing standard and the standard, the EN standard.
Correct, yeah.
So just be aware of that. These are factors, and your panel is then just EN54 Part 2, and the Part 4 falls away.
Yeah. Yeah, and we've had a couple of issues that maybe we're digressing quite a lot here, but for a panel to become, or for equipment to become EN rated, that is a very difficult, very intense testing that needs doing. And if a component in the power supply gets changed, for instance, then that whole power supply needs to be re-looked at again. It has to be re-certified. So you can't just willy-nilly change stuff.
100%.
Yeah.
But I think that's enough just on things that are brought up regularly.
Yeah.
Check your cable, label your batteries, check your voltages, make sure the batteries are right, do your battery calcs.
Make sure that you're paying for what you get. Don't just go buy fire-rated cable from the guy on the street corner. It's probably not going to be the right thing.
And check your cable ties.
That's it.
Check your fixings,
Yeah.
etc. But yeah, thanks, Clive. Thanks for your time.
Awesome.
Thanks for everyone that's watching.